Hello and welcome to our next discussion in the wonderful world of sequences, series, and probabilities. Today's discussion is over arithmetic series and sequences. A sequence whose consecutive terms have a common difference is called an arithmetic sequence. This is probably going to be the easiest type of sequence that you deal with. A sequence is arithmetic if the differences between consecutive terms are the same. So the sequence a sub 1, a sub 2, a sub 3, a sub 4, so on through a sub n is arithmetic if there is a number d such that a2 minus a1 equals a3 minus a2 equals a4 minus a3, so on and so forth, that all that is equal to d. In other words, if the number subtracted by the number before it are all the same, then there is a common difference, and thus it is arithmetic. Very simple, 2, 4, 6, 8, 10. Each of those have a difference of 2. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is, oh no, it's 2. So that is an arithmetic sequence. Now they can be more complex, but not by much. You're pretty much going up by a certain counting number. Some examples. So let's say the sequence whose nth term is 4n plus 3 is arithmetic. For this sequence, the common number, the common difference between them is 4. So 7, 11, 15, 19, so on and so forth. Every one of them is going to be 4n plus 3. In other words, it started with 3, and then it goes up 4, and up 4, and up 4. And just however many 4 that it's up depends on the number of the sequence. So, for example, if you begin with n equals 1, by plugging in n equals 1, you get 4 times 1 plus 3, which is 7. So the first number of the sequence is 7. Then the second one is 11, and the third is 15. So on and so forth. The sequence whose nth term is 7 minus 5n. So for the sequence, the common difference is negative 5. Whatever is the coefficient of n with an arithmetic sequence is your common difference. So going from 2 to negative 3 to negative 8 to negative 13. Beginning with n minus 1, n equals 1, when I plug in 1 there, I get 2. When I plug in 2, I get negative 3. Each one of them is going down negative 5. Think of a thermometer. And a thermometer, the markings on a thermometer would be an arithmetic sequence. My thermometer is indicated by tens. You could either have an arithmetic sequence starting at 0, that goes up 10, then adds 10, then adds 10, then adds 10. Okay? Or you could go backwards. Minus 10, minus 20, minus 30, so on and so forth. A sequence whose nth term is 1/4 times the quantity n plus 3 is arithmetic. For this sequence, the common difference would be 1/4. So if I were to plug in 1 for that, I'd have 1 plus 3 is 4, times 1/4 is 1. So it would start at 1, and then it would go up 1/4. So it would be 1 1/4, then 1 1/2, then 1 3/4, 2, so on and so forth. The nth term of an arithmetic sequence has the following form. A sub n equals a sub 1 plus quantity n minus 1 times the difference, where d is the common difference between the consecutive terms of the sequence and a sub 1 is the first term. So this is a standard formula that we will use today, where you have some nth term of a sequence, and when you find the nth term, so if I said find the fourth term of the sequence, the initial is 3 and the difference is 4, then your formula would be 3 plus n minus 1 times 4, and you'd plug in whatever number you're finding in your sequence. Okay? So finding the nth term, find a formula for the nth term whose common difference is 3 and whose first term is 2. So I would basically have a sub n equals 2 plus 3 times n minus 1. Okay, and then you would just distribute and simplify to get a sub n equals 3n minus 1. It's really that simple. This entire lesson, you don't have a whole bunch of exponents. This particular lesson, right now, all we're dealing with is a simple linear difference. The fourth term is 20. The 13th term is 65. Write the first 11 terms. Well, if the fourth term is 20 and the 13th form is 65, then you can find the common difference 9 times to obtain the 13th term. Therefore, the fourth and 13th terms of the sequence are related by a sub 13 equals a sub 4 plus 9 times the difference. In other words, the fourth term and the 13th term are 9 terms apart. Therefore, the 13th term is just simply going to equal the fourth term plus 9 times the difference. So given that, when you would plug that in, you would just simply solve for the difference, which is 5, which then would tell you that it's going to start with, if you base it on the formula, 5, and then it's going to go up by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Okay? So all we're doing here is we're using the formula that we just learned in the previous slide and just some basic logic about counting to solve. Using a recursion formula. So find the 9th term of an arithmetic sequence that begins with 2 and 9. The first 2 terms are 2 and 9. Therefore, they have a difference of 7. The initial term is 2. The next term is going to have a difference of 7. So your formula is a sub n equals 2 plus 7 times the quantity n minus 1. Now all I do is distribute the 7 through, and a sub n equals 7n minus 5. So then if you plug in 9 for that to find the 9th term, you get 58. All right? And that concludes today.